In this lesson, we're going to look at finding areas using double integration. In this example, we're going to sketch the region bounded by the given lines and curves, then express the region as an area as an iterated double integral and evaluate the integral. So we want to find the area between the coordinate axis, the x-axis and the y-axis, and the line x plus 2y equals 4. Let's start by graphing this. Here we have, see, our y-axis, and then we have our x-axis. And so these are our two axes, x and y. And now we want to graph our line, and the intercepts for this line we can see are when x is equal to 4 and y equals 2. So 1, 2, 3, x is 4, y is 1, 2. So we're going to draw a line between these two intercepts. And this is our line, x plus 2y equals 4. And let's fill in our area. And our area, let's make this a little bit transparent. So our area is in here. And it's a triangular shape. All right, so we want to express this area. Let me go back to black and put a little arrow, oops, at the ends of our y and x axis, a little thicker. There we go. Now if we want to express this line as a function of y, we would subtract x from both sides and then divide by 2, and we have y is equal to, and I'm going to commute these, a negative 1/2 x plus 2. So this line is the line y is equal to a negative 1/2 x plus 2. Now to find the area A of this region, we want to start by integrating from x is equal to 0 to x is equal to 4. And that is, we're going to be sort of taking slices this way, where we're adding up these areas. And the areas, each one of these areas, is going to be our y value, the height, our y value, minus 0, which means that we're going to integrate. Our inner integration is going to go from y is equal to 0 to the value of y in terms of x, which is 1/2 x plus 2. And our inner variable of integration is dy with respect to y. And our outer variable of integration is x. So there's our double integral. So when we do this, we want to first evaluate, let's put a bracket, the inner integral, and that has a variable of integration dy. And so what we're going to get is the outer integral is from 0 to 4, and the inner integral, the antiderivative of dy is y, and y is evaluated from negative 1/2 x plus 2, or from 0 to negative 1/2 x plus 2, and then we have our dx. And that means we're going to integrate from 0 to 4 of, and the fundamental theorem of calculus part 2 is f of b minus f of a. So here's our f of b, And our minus f of a, well, our f of a is we'll put a 0 in for y, and then we have dx, and that is equal to, well, the antiderivative of negative 1/2 x plus 2 is a negative 1/2 x squared over 2 plus 2x, and that's evaluated from 0 to 4, which is a negative x squared over 4 plus 2x. And since that's evaluated from 0 to 4, if 0 goes in, it just zeroes out, so we merely plug the 4 in. When we plug the 4 in, we get a negative 4 plus 2 times 4, which is 8, and so our answer is 4 units squared. In this next example, we're going to sketch the region bounded by the given lines and curve, then express the region's area as an iterated double integral and evaluate the integral. So here's our line, y equals 4x, and y equals 5 minus x, and finally, y equals 1/4 x. So let's start by drawing the graph. So here is our y-axis, and then we need our x-axis, and our first line, I think I'll do our first line in a different color. Let's try blue. So our first line, y equals 4x, that's a direct variation, which means it's going to go up 4 over 1, up 1, 2, 3, 4 over 1. So it's going to look, I'm going to go through this point here, so it's going to look something like this. And come down through this point, little squiggly there, and through the origin. So there's our line, not exactly straight, but that's the line y equals 4x. And then we'll do another line. Let's do this one in red. And this is the line y equals 5 minus x. So this is going to go through the y-intercept 5, and its slope is going to be down 1 over 1. So this is going to look something like this. It has a slope of negative 1, and this is a line y equals 5 minus x. And then let's change this up a little bit, get another color. Let's try purple, sort of purplish pink, and this is going to be the line y is equal to 1/4 x. This is a direct variation going through the origin. It's going to go up 1 over 4, 1, 2, 3, 1, 2, 3, 4. So it's going to look something like this. So this is, not exact, but this is sort of giving us a picture of what it would look like. And this is the line y is equal to x over 4. And now let's shade this in. We can shade this in yellow. We'll make it a little bit slightly transparent. So here's our region, and I'm coloring it in yellow. So we want to find that area right there. So what we're going to do here is we actually have a intercept here at 1, and and this is an x-intercept, and this point right here, where these two lines intersect, the blue and the red line, when x is 1, y is 4. So we're going to come down here, and we're going to divide the triangle that we've got here into two parts, a left-hand area and a right-hand area. And the right-hand area is going to end where the purple and the red intersect, and that is when y is equal to 4. And with y is equal to 4, when x is equal to 4, this is x equal to 4, and y is 1. So what we're going to do here is we're going to sum up two integrals. One is we're going to integrate from x equals 0 to 1. And then we're going to have another integral where we find the second area where x goes from 1 to 4. And these are all with respect to x, so we'll put our outer integral is with respect to x. And now we've got this inner integral. And our inner integral is going to be with respect to y for both of these. So our first inner integral with respect to y, we're looking at this area here, and we want to integrate from the value of what y is equal to, the lower y to the higher y. Well, our lower y is this pink line, and it is x minus 4, and our upper y is this blue line, which is equal to 4x. So we want to integrate from 1/4 x, or x over 4, to 4x. And then in our second integral here, we're looking at the right-hand shaded triangle area, and we want to integrate from y is equal to this purple line, x over 4, to the red, which is this line here, which is 5 minus x. So this means we're going to, our lower y value is x over 4, and our upper y value is 5 minus x. So this is the setup here. So now what we want to do is we want to do this integration. So our first integral, x goes from 0 to 1, and then we're going to have y evaluated from x over 4 to 4x is our inner integral times dx, plus our second area, which is going to have our x values going to go from 1 to 4, times the antiderivative of dy is y evaluated from 5 minus x to x over 4, and the variable of integration from the result of that, the outer integral, is x. And now we're going to keep going. Let's pull this over. We're going to integrate from 0 to 1, and we're going to have fundamental theorem of calculus 2. Part 2 is 4x minus x over 4 dx, plus the integral from 1 to 4 times 5 minus x over 4 dx. So let's simplify these integrands. And so the first one, if we have a 4x minus 1/4 x, well, that's going to give us 3 3/4 x. So that's going to go from 0 to 1 of, again, we have 4x minus 1/4 x, that's 3 3/4 x, which is going to be 15 over 4x dx, plus our next integral from 1 to 4 is going to be, let's fix that 4, 5 minus, and now this is 1 1/4 x, which is going to be 5/4 x dx. So if we take the antiderivative of each, the antiderivative of 15 over 4x is 15x squared over 8, evaluated from 0 to 1. And the antiderivative of the next one is 5x minus 5x squared over 8, and that is evaluated from 1 to 4. So we're running out of room here, so let's move on to the next page. Okay, so here we are on the next page, and we want to evaluate the 15x squared over 8 from 0 to 1, and that gives us 15 over 8. That's the first area, plus, let's move that up. And now we're going to evaluate the second antiderivative from 1 to 4, so we'll put a 4 in. And we put a 4 and we get 5 times 4 is 20. Let's put this in parentheses. 5 times 4 is 20, minus 5 times 4 squared over 8. So this becomes 20 minus 10. Minus, and we're going to put a 1 in. So this is fundamental theorem of calculus part 2. So it's going to give us a 5 minus 5 over 8. And let's simplify this. Let's go ahead and add the opposites. This is a negative. That becomes negative, and then of course this makes this negative and this a positive. So let's finish this evaluation. And so what we get is, see, 15 over 8 plus 20 minus plus a negative 10 is 10, plus a negative 5 and 5 eighths is going to give us a negative 4 and 3/8. So that's going to give us, let's make everything over 8, 15 over 8 plus, we do this over 8, this is going to be 80 over 8, that's our 10, minus, and we have 4 times 8, which is, let's see, 8 is 32, plus the 3 or 5 over 8, then we can add the opposite. And that gives us 80 plus 15, which is a 95 minus 35 over 8. And a 95 minus 35 is a 60 over 8. If we cut that in half, we have 30 over 4. And if we cut that in half, we have 15 over 2. And that's our area. In this next example, the integral gives us the area of the region in the xy plane. Sketch the region and label each bounded curve with its equation and give the coordinates of the points where the curve intersects. Then find the area of the region. So here's our integral. Our outer integral has a variable of integration y going from 0 to 12, and our inner integral has a variable of integration x going from 1/2 y squared to 6y. So since our outer variable of integration is y and it goes from 0 to 12, we know that if we draw our y-axis, it's a little squiggly there, our y-axis is going to go from 0 to 12. Here's the x-axis. So y goes from 0 to 12 units. Okay, so that 0 to 12 is for the 0 to 12 here in the y direction. Now we want to look at the values of what x will equal. X is going to go from 1/2 y squared to 6y. So let's start looking at our lower bound, the 1/2 y squared. We're saying that x is equal to 1/2 y squared. So that is going to be a parabola. Matter of fact, if we want to think about what that looks like as y is a function of x, we would multiply both sides by 2, and y is equal to, let's say plus or minus if we want, the square root of 2x. And that's going to look something like this. This is the line, x is equal to 1/2 y squared. Now our other line says that x is equal to 6y. And if we want to think of this as y is a function of x, well then we're saying that we would say that y, put a y there, is equal to 1/6x. That's a direct variation, and that's going to look something like this. And this is the line, x is equal to 6y. So the area that we're looking at is this area right here. So now let's work on the next page. Let's work out the integral. Here you can see our outer integral goes from 0 to 2x, and our variable of integration is y. Our inner integral is going to be with respect to x. So it's going to be 6y minus 1/2 y squared. and we take the antiderivative of that integrand with respect to y, we're going to get 3y squared minus y cubed over 6. And that's evaluated from 0 to 12. And you can sort of follow this. If we plug in the 12, we get this. And you can sort of follow the work through and find that your final answer is 144.